Hi, this is the YouTube channel for Math Contest Go Go Go. What I want to do for this channel is to build a platform for math lovers in order to make them discuss about different kinds of math problems. I will update a video about challenging problems every day. If you would like, please subscribe below. Hi, this week we are going to talk about a quadratic equation, right? So, what is that? But first we need to know the definition of quadratic equation. By definition, quadratic equation is the equation with the graph of this or this, and has a formula like this, which a is not equal to 0. Yes, so this is how quadratic equation look like. So let's talk about how to solve the quadratic equation. So we need to divide it into some cases. First, it's a is only equal to 1. So it has a unique solving ways compared to a is equal to other numbers. So which it is look like this. So the goal of us is for solving this is to divide it into a cases of this to make it more solvable, right? So to do this, it's not this. It's not necessary this. It should be this to make it solvable. So let's try expand this, which is like this, right? So it looks like this after we simplify it. And it will eventually, we can write it in the form, which is this is equal to b and this is equal to c. So this is the core point for us to solve this. So these are the two final, so you are able to first find a and c. And then if you find a and c, then you put them in. Let's make an example. Right, x squared plus 7x plus 12. Well, let's use the same way. We know that 7 is this and 12 is this. So we know that it will lead to this. Okay. Now let's talk about what is the root. The definition of a root in a quadratic equation is that the root is the solution of x. Right? So we know that, let's make an example. So we know that there is a function that looks like this, right? So we expand, so we simplify it into this. So we know that x can be equal to -3 or x can be equal to -4. So these are the roots. Now let's talk about the ultimate cases where a is equal to other number. Sometimes you know that this way, it might not able to solve all problem with a is equal to 1. So let's make an example. So x is equal to 5x plus 168. So we know no matter what this, how many times we try, no matter what we do to put 168 into 2 factors, they will, when they add up, they will never equal to 5. So in this way, we are going to like do an equation to completely solve the problem. So this is what the quadratic equation formula is. Let's define when this is equals to 0, right? When the equation is this. So we want to know what x is, right? So there is a formula. X is equals to this. Yes. So how can we get this? Which x is equals to this. So how can we get this equation? This is what we need to discuss about. Okay. So we know that there is this formula looks like this, right? First, we divide both sides by a, which this is still equal to 0. And this is equals to this, right? And then we rearrange this formula into this. So what happens next is going to be very important. So we put a 2 here, times 2 here, and put a divide 2 here, so that the result won't change. And then we put a b plus 2a squared on both sides. Uh-oh, sorry, that was a mistake. Here. So we know that it is going to be equals to this. And then, with some simplification, we can know that this is equals to this. Yes, so with some attempt, you are able to find that this is equal to this. And the right side is still this. So let's do the right side. So we expand the right side. It will be equals to this, right? So which this is equivalent to this. Yes. And as we know that we have said that this has the side of this one. Right? Then we add the square roots for both sides. So which this will be this will be this. And this will be this, right? So we get this. Now we do is we minus, we solved it. We put this formula in the shape of this. Minus b plus 2a. So well, the last step is a bit hard, like you need to infer that x has 2 roots, right? Well, in this formula, we can only prove that x has 1 root, but like based on the graph of the quadratic equation, like you are able to know that every point except the climax, I mean the extrema, has 2 points. So use this, we can make a considerable inference, and we know that the 2 formula, like the 2 results of x are negative b plus b squared minus 4ac divided by 2a and negative b minus b squared minus 4ac divided by 2a. An important knowledge here is like for us is to know like how many roots like it has. As we know that not all like quadratic equation has 2 roots. The climax here will have 1 root, while this, well, at some extreme cases there will be no solutions. I mean no real solutions. Remember, no real solutions. Okay, so we can make it so how we know that it has 2 solutions, 1 solution, or no solution is majorly based on this. Let's make an inferable guess. So we know that if this is larger than 0, it will have 2 solutions. So this means that it's going to be a number. So which means that it will have 2 results like this and this, which these 2 results are going to be different. So if this is equal to 0, then it will have 1 solution, because negative b plus 0 and negative b minus 0 are the same. What if it is less than 0? Okay, unfortunately, it won't have any solution, because that if a number inside the square root is less than 0, it will only result in imaginary number. So that's why we call it has no real solutions. No real solution. So we just say that it won't have any real solution if it has a case of this. So let's make an example about like how to solve this. So we do a 2x squared plus 5x plus 13 is 0. First we write the a, b, and c. What's c? Okay, sorry. C is 13, yes. So to solve this, what we need to do is we need to do this. Negative b is 5, right? Plus or minus 5 squared minus 2, 4ac, 4ac divided by 2a. We know that this is less than 0, so therefore it won't have any solutions. So let's make an example again. So what if we change it to this? Plus b squared minus 4ac. Okay. So we change this into this. Let's see the solution. So it's negative b plus or minus b squared 49 minus 4ac 24. Negative plus 5 divided by 2 and negative minus 5 divided by 2. Which one solution is negative 1 and another solution is negative 6. So we put them back into the 4ac, right? So we put them back in the formula. sorry, it should be 4. I omit an A here. So it should be this. So which one solution is going to be -4 and another is going to be -3. So now we know that it has 2 solutions. This is an example that has 2 solutions. Now let's talk about the extrema of the point. So we know that we can use this way to about finding a correct extrema, which having an extrema will help us a lot in some problems. So we know that we restate the quadratic equation. So this is the equation this is the point where the extrema lies, which is here. How are we able to find that? Let's restate the quadratic formula. It's like this. We know that only at extrema points this will equal to 0, right? So which means that it will be omitted into this, which it will be result in this. This is how we find the points of extrema, yes, in this case. Now let's solve a real-time problem. So we know that there is a 22 centimeter fence, and we wanted to put it into 30. We wanted to have we wanted to have an area of 30 square meters. So, and we want the length of, the perimeter to be 22 cm. So how should we build it? Is it able to be built? To do this, we set this as x and this as 11 minus x. So this is equals to 30. So 11x minus x squared plus 30 is equals to, minus 30 is equal to 0. So we know that is this, right? And using any way we are able to, we multiply -1 on both sides to make it easier. So it's like this, right? So it's x minus 5 and x minus 6, where x is equal to 5 and x is equal to 6. So there are 2 ways to do it, which is both length 5 with 6 and with 6 length 5. So this is how we use the quadratic equation to solve real-time problems. And here, we come to the end of this video, and I hope you can subscribe this video. Thank you. See you next week. So we now will talk about Vieta's formula. Vieta's formula is a law that can results in the 2 coefficient. So it is very important for us to know that. By definition, if we set the 2 coefficients as x1 and x2, then it will have a formula like this and this, respectively. Okay. How can we get that? Well, getting that is the easiest step compared to this. So we know that two results are this, right? So we just write this plus this. So it is equals to this, which is equals to this. Another rule, like, so we get this, like, what we do is we, like, put it in here again. Which it looks like this. So we know that after a bit simplification, we are able to get this. Which this is going to be equivalent to this. So this is how we get the two formulas here. Let's make an example. So let's still recall this. Right, let's make this formula again. Find the two roots of him at this point, right? So we know that using Walter's formula, like x1, x2 are going to be equal to this, right? So in this case, let's solve it, which x1 is equal to 3 and x2 is equal to 4. Sorry, it should be negative. Both should be negative. Since it is negative, b divided by a. So it should be like negative 3 and negative 4. So here is a completion of Walter's formula. Finally, let's solve it in real-time problem. Okay. Let me think about a problem. Now let's solve a real-time problem. So we know that there is a 22 centimeter fence, and we wanted to put it into 30. We wanted to have a, we wanted to have an area of 30 square meters. So, and we want the length of, the perimeter to be 22 cm. So how should we build it? Is it able to be built? To do this, we set this as x and this as 11 minus x. So this is equals to 30. So 11x minus x squared plus 30 is equals to, minus 30 is equal to 0. So we know that is this, right? And using any way, like we are able to, we multiply -1 on both sides to make it easier. So it's like this, right? So it's x minus 5 and x minus 6, where x is equal to 5 and x is equal to 6. So there are two ways to do it, which is both length 5 width 6 and width 6 length 5. So this is how we use the quadratic equation to solve real-time problems. And here we come to the end of this video, and I hope you can subscribe this video. Thank you. See you next week. In fact, problems, they have many solutions, and my solution is only a part of them. If you have more challenging solutions, please comment below. And don't forget, I will also post my problems there. See you tomorrow!